square. But I only drew it out to here, and really this thing's supposed to be symmetric. So this whole thing's supposed to come out this much further over here. So there is a 4x4 square. See if the goes up. Yes, it's a little more symmetric. Okay, so anyhow, so I got my depth versus time, the picture I used previously, and I subdivide. Okay, so I subdivide the interval from the red dot to the left edge in half. I subdivide that in half. Okay, I could do the same thing on this side, but I'm not going to need this side because this is outside the domain of our function. I'll put a couple lines in there. Okay, then I'm going to subdivide it this way, half interval from 0 to the top and half interval from 0 to here and half interval from 0 to here and half and interval from 0 to here and half. Now the points on this parabola, and I haven't even looked that closely, although one of them did kind of look. I don't know how this is going to work out. I'm really kind of nervous about this. I don't know how this is going to work out. I don't know if I drew a good parabola to start with or not. Hit or miss. Okay, I'm not that great at drawing parabolas. Okay, so with these subdivisions in this rectangle, I should have a point here. I should have a point here. And I should have a point here. A point here. Well, this point naturally works. This point came out pretty good. Now this point, either I subdivided wrong or I just made the parabola too steep and then, okay. So I didn't do a great job at this point because the ideal parabola should go through this point, this point, this point. Assuming I did all this correctly and carefully. And then on the other side, actually kind of worked out better here. This point seems about right. And this point doesn't seem too bad. Okay. So my original parabola was fair. Now what you see from what I've done here is that if you know where the red dot goes and another point on the parabola, you can see whether you've got a good parabola. Sketch. Okay, so let's do this one. Okay, I don't know how to do that parabola is. I suspect it's not that great, but there it is. And then we have this point. So using a vertex in this point, I can sketch a rectangle. You know, the rectangle goes way over here, and there's an edge over here. But I'm really only interested in what happens from here to here because that's my water stream coming out of the tube at the bottom of the cylinder. Okay. Well, I divide this interval in half. Divide this in half. Divide this in half. I'm not being overly careful about this. Then from the red dot out to the extreme, divide it in half. Divide that in half. Divide that in half. And my points should be here. Now the curve is a little high at that point, but it's pretty close. Okay. And I divided it in half one too many times. It should have gone through this point here. It's a little high. I got a little too flat at the top. So I didn't do a great job on that one either. So don't feel bad if you don't do a great job, but you want to make yourself feel good. If you find this not too difficult, see how much better than me you can get. Okay. Okay. The whole point of this is that the subdivision process and the rectangles and stuff adapt to any parabola. If you have data and you want to fit a parabola to it, you can take a sketch and do the subdivision, see what the parabola would look like. There's analogy to this with the algebra, and you've had the algebra if you've had algebra 2, but that algebra is just a little bit challenging. So in this course, it's going to take a while to build up to where we're doing that much algebra. But you can, if you know the coordinates at this point, know the coordinates of the vertex, you can set up a couple of simultaneous equations. They're not that hard to solve, and you can come up with a good model, something like this one. Okay. Again, don't worry about that right now, but that's something we get to do later. And hopefully that stimulates a little bit of your curiosity.